Uh, One, okay, this video is the mechanics of materials. Okay, and this video I'm going to show you a problem on your homework is a rigid body equilibrium. Okay, and this problem is calculate the reaction from the support. Okay, so here is the problem. I think there is also a beam. Okay, but the beam, the shape is not okay, this beam has an extension here, and this extension has a join with the normal with the normal beam. Okay, and this beam we have apply some external loading. This 6 kilonewton point down, and this 4 kilonewton point pulling in this way. And this problem want to calculate the reaction from the fixed support. Okay. Okay, and use the rigid body equilibrium, and it's a 2D, so we only have three equations: sigma fx, sigma fy, and the total moment of the system. Okay, okay. Let's start with this calculation because the whole thing in mechanics of material, everything is static. Everything is static. So, rigid body equilibrium, no translation and no rotational motion. And okay, so the static, okay, statics, okay, the rigid body equilibrium. So in 2D we have three equations: summation fx equal to 0, summation fy equal to 0, and summation moment also equal to 0. That's the equation we're going to use. Okay, let's start with it. Okay, and we have fixed support here. Okay, the fixed support will create a reaction force and reaction moment, and we assume, okay, reaction force is like this. We have reaction force, okay, AY point up, AX point to the right, and we assume there's a moment, reaction moment, and we assume the reaction moment is counterclockwise. We call it MA. Okay. Okay, so and let's start with this calculation. Okay, first of all, summation fx equal to 0. Okay, so we look at what do we have any x component force? Okay, here is the reaction. Okay, reaction force ax, reaction from this fixed support, so it's ax. Okay, and this vertical, so there is no x component. And here is 4 kilonewton here, and we can decompose the force because it's very, very clear. It's give you this force is 30 degree with respect to this horizontal line. Okay, so we can decompose this force like this. Okay, so this 4 kilonewton times cosine 30 degree, and here is 4 kilonewton times sine 30 degree. Okay, so this is x component force, so and it's point to the right, so it's plus 4 times cosine 30 degree. Okay, don't forget this, we use the kilonewton as a unit. Okay, and ax plus this force, and I think that's all the horizontal or all the x component force we have, and equal to 0. Okay, so from this equation we can solve ax, but we can solve later. We continue to list the equation, so and the summation fy I write here equal to 0, so we have a1 point up and 6 kilonewton point down, so minus 6, and we have vertical force here point down, so it's point down, so it's minus 4 times sine 30 degree, and it's totally equal to 0. And okay, use this equation, yeah, we can solve the ay. Okay, solve the ay directly. Okay, and the final one is the sigma, the total moment is the whole system total moment is equal to 0, and we assume there's a reaction moment here is ma, so you have to write, so they have to write it out, and we use a as a reference point. And we have reaction moment from A, so we still have to write it out, and it's counterclockwise. And okay, we see this force, this kilonewton point down. Okay, this will create a moment with respect to A, and this will point down reference point is here, so we will create a clockwise rotation, so it will become a negative, and so negative, so it's clockwise, so it has negative, and the force is 6, and lever arm is 1.5, And also here we see, okay, so we have to be careful for this, okay, the moment calculation, okay. And yeah, of course, the vertical force will create a moment with respect to A, because we will draw because force, we will make an extension here because this is the vertical force here. Okay, and you see the lever arm is here. Okay, maybe I use the more bright color. This one, there's a lever arm here. Lever arm is here. So this here is the force, and here's the lever arm. So this vertical force will create a moment, and it's 4 kN times sine 30 degree. And the reference point is here, so it will create a clockwise rotation. So it will so it's negative. And what's the lever arm? Be careful for the lever arm is 1.5 plus 1.5. And what's the lever arm? Distance here is 1.5. Yeah, here it tells you this 1.5 and cosine 30 degree plus 1.5 times cosine 30 degree. Okay, and the final one, will this horizontal force create a moment with respect to A? Yeah, be careful. If this horizontal force is acting at here, and there won't be any moment. There won't be any moment. Okay, but this force is here. Okay, and we draw an extension of this force. So it's called line of action. So force is a sliding vector, so you can make an extension. Okay, let's draw a line of action. Okay, and you see, if you draw this extension of this force, you will see there's a lever arm of this force. The lever arm is here. Lever arm is here. Lever arm is here. And what's the distance here is 1.5 times sine 30 degree. 1.5 times sine 30 degree. So this horizontal force will also create a moment. Okay, be careful this. But if this horizontal force is acting at this line, and there won't be any moment. But it's acting here, so there's a lever arm here. So we still have to write this out. Okay, so this force here in reference point A is here, so it will create a clockwise rotation. So it will be negative, and the horizontal force is 4 kilonewton times cosine 30 degree, and its lever arm is 1.5 times sine 30 degree. Okay, so totally you equal to 0. Okay, and then we can use this to solve the MA. Okay. Okay, finally we solve okay, finally we get the all we can solve all the reaction force from A. So let's try. Okay, that's what's the AX. AX is equal to minus, okay, let me see my answer. I think it should be minus 3.434, it means kilonewton. And initially we assume it's point to the right, but we get a negative answer. That means it's the real direction is point to the left. Okay. And for AY, what's the AY? AY will be, okay, if you use your calculator, don't forget to use your calculator. The AY will be 8 kilonewton. And it's point up. Okay, we initially assume it's point up, and we get a positive answer. That means it's really point up. Okay, finally the moment. Let me check my equation. Is my equation correct? Okay, let me check. Okay, I have to check this because yeah, this is correct. Yeah, this equation is correct. Okay, so you just use the calculator by yourself. Okay, don't forget how to use the calculator. So and finally we'll get the MA is equal to I think. Okay, and let me give you the answer. This is minus 9. Okay, oh sorry, this is 9. Okay, and mm, this is 2.598. This is 2.598, and here is 8.598. 8. So do the overall calculation, you will get MA is 20.196, and then don't forget unit is kilonewton times the meter, and we get a positive value. Okay, positive, I think. Okay, we initially assume the reaction moment is counterclockwise positive, and we obtain a positive answer. That means it's really counterclockwise. Okay. So, okay, that's the reaction force calculation for this problem. And this problem, don't forget, if you do the moment calculation, don't forget this force also create a moment. Okay. So when you do the moment calculation, okay, draw the line of extension and find the lever arm. I think that's the most difficult part, is just determine the lever arm. It's 2D calculation, 2D moment, 2D calculation, and you want to calculate the moment. The difficult part is determine where is the lever arm. Okay, what the lever arm is. Sorry. Okay, so here's the problem 4.5, and I just start video here, and I will see you in the next video. Bye bye. Okay, see you next video. Bye bye.